some technical difficulties here, guys. Sorry. So for our last one, we know that this, hopefully you see this is not a direct subtraction. So in this case, it would be minus 15, but minus 15 would not give me 24.5. So we know we're doing exponential. And this is not as nice and neat as doubling or tripling or any of those things. But ideally, if it was getting larger, it's multiplication. So as it grows, it's multiplication. And earlier we multiplied by 1/2, which is, like I said, really dividing by 2. So if it's decay or goes down, decreasing, it's going to be division. And the idea would be, how did I get from 50? 50 divided by what gives me 35, right? 50 divided by what gives me 35? Or if you want to think 50 times what gives me 35. So 50 times what number, if we like multiplication, gives me 35. So that would end up being, so 50 times what gives me 35. We need to find x, so we're going to divide by 50. So 35 divided by 50, and you would do that in your calculator. It's going to be 0.7. It's going to be 0.7. So then the multiplication, if you like multiplication, which most of us do, is 0.7. So we'll check it. So 24.5 divided by 35 is going to be 0.7 again. And we'll check it one more time. So 17.15 divided by 24.15 is going to give, or 24.5, I just messed up. I was going to find one that didn't match. 0.7 as well. So it's on the path of 0.7. 0.7. So we're multiplying by 0.7. So it's 70, it's decreasing by 30%. Because remember, 10, 0.10 would be, or 0.1, or 1.0, I'm so sorry, 1.0 is 100%. So in this case, this is 70%, right? 70%, which is less than 100%. So it's getting smaller. So this is going to be a decay. So again, your starting amount is what is your value when x is 0, which is 50. And we're multiplying by 0.70, and it's raised to the x because it is an exponential function, is how we would track it throughout. And again, it's decay. Another big call out, which you'll pick up more tomorrow, is if the number within your parentheses is less than 1, remember it's decay. Oops, didn't spell it right. Decay. So it's going down. So it's all relative to 1. And I like to think of a dollar because it's usually decimals in this game, unless it's double, tripled, and then we can still think about those as dollars. But we'll do more of that tomorrow with the decimals. But if it's more than $1, it's growth. If it's less than $1, it's decay. And if it's decay, we're losing. In this case, it's all relative to that dollar. We lost 30 cents every time we went down. We lost 30 cents or 30%, right? So it was a 30% decay in this case. All right, so next page, last page for today, so we can practice some more types of growth and decay. So we want to define or identify growth and decay from, decay, exponential versus linear. So exponential versus linear, just for the equations. So I challenge you to pause it. See, just put an E or an L for which one you think is linear and which one you think is exponential equations, okay? So pause now and give it a try. So our x is in the exponent spot. It's not a mx plus b, because remember, linear is y equals mx plus b. Exponential is y equals a times b to the x power. And the x up in the exponent spot is what makes that exponential. So we know this is exponential. This is very y equals mx plus b, linear. X is in a straight line, so this is going to be linear because it's not in the exponent spot. This is 1.75x minus 4, so that is a number with a base. This is a base with an exponent of x. So the exponent is x, so we know this is exponential. Again, a little out of order, but again, we have our base and our exponent is x, so this is exponential as well. Y equals x. Hopefully you remember that's that perfect diagonal line, and this is going to be linear. Y equals mx plus b. In this case, again, we have another linear. Base with an exponent, so that's going to be exponential because the exponent is the x value. And then base with an exponent again. Now, just for conversations to get a little bit of a head for tomorrow, on our exponential function, is our b value less than or greater than 1? In this first case, it is greater than 1, so this is going to be growth. It's going to be getting bigger all the way through. It's going to go up. It's going to increase. For this guy, our front value is greater than 1. So again, it is also growth. It is going to, from left to right, go up. Again, greater than 1. So this is growth as well. So it's a positive exponential. greater than 1, so this is growth as well. So it's going to go from left to right. It's going to go up in this form. All these growths kind of look like a half pipe like this, right? And then our last one, this is less than 1, so we know this is decay because it's less than $1. So what I was talking about a minute ago, less than $1. So it's going to look more like this. So as you read from left to right, it is going to decrease in a graph form if you're looking at this picture. And then we have 6 graphs. Hopefully these are super easy. And just for review, we're going to write the equations of our linear functions and identify our initial value and our exponential functions at this point. So our first one, actually pause the video, just out of his linear exponential, all 6 of them, please, and give it a shot because you need to practice and figure out where you're going to mess up now. All right, so we know this is linear. Straight line, right? Y-intercept is there at 3. It looks like we have another good one here. So that means 1, 2, 3, 4, 1, 2. Oh, there's a good another one there. So 2 to 1, 2 to 1. So our slope is rise 2, run 1. It is increasing to the right. So it's going to be y equals 2x plus 3. Our next one has that nice swoop or the half pipe curve. So we know this is exponential. And our a value or our starting point is 1. Beautiful. Now, you could also go back once we start practicing and you can find all your good points and plug this in to your calculator or to Desmos and find out what the actual equation is. But we'll worry about that tomorrow. Right now, you're just identifying that it's exponential and identifying that the starting point or initial value is a positive 1. All right, so we have a 0, 0 initial value or starting point. This is linear. It's negative. It's going to a 1-to-1 slope. So that's going to be y equals negative 1x. And again, this is linear. And the negative 1 may not be there. You may just see negative x as always, right? All right, so this one is exponential because it is a curve. And our starting point or our a value is 5. The next one, again, is a curve, but it's turned different because it's definitely not linear because it's not a straight line, but it's going down. So this is going to be exponential as well. And then getting ahead of the curve, this is decay because it is going down. It is decreasing from left to right. So our a value on this one is also going to be 1. Then last but not least, this is linear. This is that horizontal line crossing through at 2. Hopefully remember horizontal is your HOI. So that means it's y equals 2. All right, guys, that's your introduction of differentiating between exponential and linear function and just a basic intro into exponential functions.